I'm just going to do the C part. In the C part, it's saying, okay, I'm looking at the 9.3 question. C part, it's saying ID1 is equal to 0.16 milliampere, ID2 is equal to 0. So we have to find out VID in this case, that's input differential voltage. And also we have to find out the VS, VD1, VD2, and also VD2 minus VD1. Okay, now let's go ahead and do all them one by one. So first we need to find out the VID. I'm doing the C part. And if you notice, we have ID2 is equal to 0. It means the Q2 is just cut off. So only Q1 has current flow, which means the VID is going to be square root of 2 VOV. And square root of 2 VOV is, I calculated in my previous video, that one to be 0.2 voltage. That is over, you can watch my previous video to look at it. So here we overtry, that is 0.2 voltage. So we have already that value, that is 0.2. Plug that in, and if you solve for that, that's become 0.283 voltage. Okay, so now we have the input differential voltage, and the question is also asking for the VS, and in my previous video I derived an equation for VS using the current equation. If you rearrange the current equation in terms of VOV, you will get this, and you can change the VOV equation in terms of VS by doing some changes. So I derived it over here. So that is VS is equal to VG minus VT minus square root of 2 ID1 divided by Kn prime W over L. Okay, VG is nothing but VID, it's mentioned in the question. vG2 is 0, but we are looking at vG1, that is equal to VID. Since VID is already available to us, we can say this is equal to vG1, and that's the gate voltage we have to use right here, that is 0.283. And then V threshold is provided, we are looking at 9.1 for the parameters, and in that one we have the V threshold, that's 0.4, and then minus square root of 2, and in this one the current given to us is 0.16 milliampere. So plug that one in, 0.16 milli, and then Kn prime is given to us right here, that's 0.4 milli, and W over L also provided to us, that is 10. Plug that all in, solve for this, you will end up getting VS to be negative 0.4 voltage. And the next thing we have to find out is VD1 and VD2. To find out the VD1, we plug in this equation. VD1 is equal to VDD minus I divided by 2 RT. This is I divided by 2 because that's the current flow through this, but the current flow through this is already provided to us in the question, that's 0.16. So instead of I divided by 2, we have to plug that one in. So let's write this equation first. VD1 is equal to VDD minus I divided by 2 times RD, and VDD is 1 voltage, that is given in this question right here. Here we look for the parameters. VDD is 1 voltage, and then minus I divided by 2 is the current flow through this, that's the drain current, but that's already available to us, that's 0.16 milliampere. So instead of I divided by 2, we can put 0.16 milli, and then RD is provided in the question right here, that's 5 kilo ohms. So I plug that one in, 5k, and that gives us VD1 to be 0.2 voltage. And VD2, same equation. VD2 is this one right here, exact same equation. VDD minus I divided by 2 RD. In this case, this is a little bit easier because the current for this one is 0. So because that is given in the question, ID2 is 0, so this whole thing is 0, so this is just 1 voltage. And we had to find out VD2 minus VD1 as well. That is output differential voltage, that is VD2 minus VD1. And VD2 we just found out to be 1, and VD1 is 0.2, so the output differential voltage is going to be just 0.8 voltage. And that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.